Hey, so if you're anything like me and you've been on the internet recently, you've probably seen these photos or images of these AI generated fruits or whatever on the internet. And these images and pieces of content are created through a model called Stable Diffusion. Now, Stable Diffusion, how it works is it repeatedly denoises a random image until it produces data. And this process is notoriously difficult and inefficient to run, and it's very expensive to run. So, why? What gives? Well, the denoising process kind of involves a lot of convolution and matrix multiplication operations. Now, whilst these two are very optimized in traditional GPUs and AI accelerators are more optimized for large chunks of one of these operations at a time. For example, a large chunk of linear matrix multiplications. That is putting it in a much more simplified way. However, a diffusion algorithm requires switching between the two operations with each denoising steps multiple times. So this introduces a lot of overhead with if using traditional accelerators with how they are implemented in the hardware level. Now, how are we addressing this? In a paper called, it's a pretty long name, so I'll let you read it. Basically, it introduces and proposes a solution called a standard diffusion accelerator that stable diffusion accelerator that generalizes the matrix where these operations are performed in, and also introduces a new combinational block that directly calculates the relevant addresses that are needed for the operations, so that one, it reduces the overhead of each of the operations, and two, it also reduces the overhead specifically of the convolutional operations by kind of injecting addresses directly into the operation rather than what was done more traditionally, which is an image to column process that also uses a lot of extra memory. Now, we can go way deeper into this, however, it's a 2 minute video, so that's kind of the gist of it. Now, what we did for this hackathon was we took the findings of this study and we wanted to verify it and also see whether or not it actually does perform better empirically compared to a traditional GPU or hard AI accelerator. And we found that it does. It introduced a 32 times reduced amounts of memory reads and sorry, let me pull it up. So it introduced 32 time amount reduced memory reads, as well as reducing the buffer time between the convolutional layers and the matrix multiplication layers. And this would significantly increase the efficiency of a standard diffusion model when being run on a chip accelerator with this new architecture.